Hello, good day everyone. Today our group are going to tackle about the sense of hearing, but before that let me introduce ourselves. We are from Sulu College of Technology, partaking the course of Bachelor of Science in Nursing Level 1B. I am Janister Aberin along with my group mates Ayesa Sakkam, Aisa Sadri, Zairalin Hassan, Riznalin Haluddin, Roslyn Sangkola, Denrasar Zahirun, Fatima Riza Iking, Jernalin Arakama, Fatma Riza Yusuf, Mazda Taha, and Surfaida Akdam. So, our group's objectives, which is to define the anatomy of hearing, cite the structures, cite the transmission of the sound, define the physiology or function of hearing, express the normal and abnormalities of hearing, cite the hearing process, cite the causes of hearing loss, and cite the prevention of hearing loss. So let's tackle about the anatomy of hearing. Hearing starts with the outer ear. When a sound is made outside the outer ear, the sound waves or vibrate, and it travels down the external auditory canal and strike the eardrum, which is called the tympanic membrane. And the ossicles amplifies the sound. So they send the sound waves to the inner ear and goes into the fluid-filled hearing organ, which is called cochlea. So the ear is the organ of hearing and balances. The parts of the ear include external or outer ear, consisting of pinna or auricle, external auditory canal or tube, tympanic membrane or eardrum. So pinna or auricle, it is the outside part of the ear. External auditory canal or tube is the tube that connects the outer ear to the inside or middle ear. Tympanic membrane or eardrum. The tympanic membrane divides the external ear from the middle ear. Then, the middle ear or tympanic cavity consisting of ossicles is eustachian tubes. So, ossicles, there are three small bones that are connected and transmit the sound waves to the inner ear. The three bones are called malleus, incus, and stapes. Eustachian tube, it is a canal that links the middle ear with the back of the nose. The eustachian tube helps to equalize the pressure in the middle ear. Equalized pressure is needed for the proper transfer of sound waves. The eustachian tube is lined with mucus, just like the inside of the nose and throat. The last is inner ear, which consists of cochlea, vestibule, and semicircular canals. Cochlea, this contains the nerves for hearing. Vestibules, this contains receptors for balances. And semicircular canals, this contains receptors for the balances of the sound waves. In summary, the ear consists of a sound conducting mechanisms and a sound transducing mechanisms. The sound conducting mechanisms has two parts, which is the outer ear consisting the pinna and ear canal, then the middle ear consisting the tympanic membrane. So, the ear is divided into three interconnecting sections, which is the medial, which is the external, middle, and inner ears. So, you can see that in the structures of the ear in the next slide. While the external and middle ears are mainly concerned with the transmission of sound, the, the inner ear contains the cochlea, so it often called the organ of hearing, and it also houses the body's organs of balance.
Structure of air, the outer air. The outer air include the portion of the air that we see, the pinna, auricle, and the air canal. Pinna. The pinna or auricle is concave cartilaginous structure which collect and direct sound wave traveling in air into the air canal or external auditory mesh. The medical term for the outer air is the auricle or pinna. The auricle air is made up of cartilaginous skin. Air canal. The air canal or external auditory meatus is approximately 1.25 inch long and 0.25 inch in diameter. The inner two-thirds of the air canal is embedded in the temporal bone. The outer one-third of the canal is cartilage. Although the shape of each air canal varies in general, the canal form an elongated S-shaped curve The air canal directs airborne sound wave toward the tympanic membrane eardrum. The air canal resonates sound wave and increases the loudness of the tone and the 3400 Hz range. The air canal maintains the proper condition of temperature and humidity necessary to preserve the elasticity of the tympanic membrane. Glands which produce cerumen, airwax, and tiny hair in the air canal provide added protection against insect and foreign particles from damaging the tympanic membrane. So, air canal or auditory canal is a tube that runs from the outer air to the eardrum. The air has outer, middle, and inner portion. The air canal and outer cartilage of the air make up the outer air. The air canal transports sound from the outer air to the eardrums, which is the middle ear.
So now let's proceed to middle ear cavity. So the ear is divided into three parts. The outer part is made of the pinna as well as the external auditory canal. The next one is the middle ear or the tympanic cavity, and the final structure of the ear is the inner ear. So in this video, the ear is divided to three parts called as outer, middle, and inner ear. The middle ear actually extends from the tympanic membrane because the tympanic membrane is the lateral structure of the ear, and it extends toward the inner ear, that is lateral structure of the outer layer wall of the inner ear. So, what are the extension of the middle ear, guys? It extends from the tympanic membrane laterally as well as to the neutral wall of the inner ear, medially right. So, this is where you can see the middle ear cavity, which is called as the tympanic cavity. Coming to the division of middle ear. The middle ear can be divided into two parts. The first one is called as the tympanic cavity, and the second one is called as the epitympanic recess. So, let us discuss the tympanic cavity. The tympanic cavity, also called as the tympanum. So, here the tympanum, nothing but is immunitize the region. So what is the meaning of immunitize the region air? It is nothing but the air-filled region of the temporal bone that lies just medium to the top of tympanic membrane. So what is the tympanic membrane? We will also call the tympanic membrane as the eardrum. So remember that the tympanic membrane, also called as eardrum, the middle ear is located at the lateral to the top of the promontory. So what is the promontory? The promontory will nothing but cause by the bones, the tones of the cochlea of the inner ear. So now let's talk about the segment tympani. The tegment tympani is nothing but a laminar projection of the petrous part of temporal bone that is forms the roof of middle ear cavity is nothing but called as the tegment tympani. It is a laminar projection of the petrous part of the temporal bone which form the roof, and it contains, especially if you see here, the middle ear contains the three important bones, the malleus, incus, and stapes. Transmit the sound vibrations from the tympanic membrane, extending toward inner ear binding of these three important tiny bones which is present in the middle ear. So, Eustachian tube. So let's talk about the Eustachian tube. It is also called as auditory tube. It connects pharynx to middle ear, which is developed from first pouch to length of Eustachian tube is nearby 36 mm. The narrowest part of Eustachian tube is isthmus. It has two main functions. First one is maintain middle ear pressure, and the second one is train the secretion of middle ear. So let's proceed to inner ear. The inner ear is composed of sensory organ of hearing, the cochlea, as well as for balance. The vestibular systems are separate, yet both are incised in the same bony capsule and share the same fluid system. So that the cochlea is spiral shaped and similar shape of a snail. And the cochlea is composed of three fluids that extend the length of the structure. There are two outer chambers are filled with a fluid called perilymph. So perilymph is an agent for the delicate structure that occupy the center chamber. It is important to note that perilymph is connected to the cerebrospinal fluid that surrounds the brain and the spinal column. So the third fluid-filled chamber is the center chamber called the cochlear duct. So the cochlear duct secretes a fluid called endolymph which fills this chamber. So the cochlear duct contains basilar membrane which lies the organ or corti. Organ of corti is the sensory organ essential to hearing. It consists of approximately 30,000 finger-like projections of cilia. These cilia are referred to as hair cells. Hair cells is connected to a nerve fiber impulses to the cochlear branch of the cranial nerve or auditory nerve. So the pitch of the impulse relay is dependent upon which areas of the basilar membrane enhance which portion of the organ of corti are stimulated. So, the central nervous system carries impulses generated from the organ of corti to the brainstem. From the brainstem, nerve pathway extends through numerous nuclei to the cerebral cortex in the temporal lobes of the brain. So, it is in the temporal lobes of the brain that meaning is associated with the various pattern of nerve impulses.
Transmission the sound to the central nervous system. In order for a sound to be transmitted to the central nervous system, the energy of the sound undergoes three transformations. First, the air vibration are converted to vibration of the tympanic membrane and ossicles of the middle ear. This in turn become vibration in the fluid within the cochlea. Finally, the fluid vibration set up traveling waves along the basilar membrane that stimulate the hair cells of the organ of corti. These cells convert to the sound vibration to the nerve impulse and the fibers of the cochlear nerve, which transmit them to the brainstem from which they are relayed after extensive processing to the primary auditory area of the cerebral cortex, the ultimate center of the brain for hearing. Only when the nerve impulse rates these are the listener become aware of sound. So when we say transmission, it means the action or process that transmitted the sound to the central nervous system. So when the sound to be transmitted to the central nervous system, the energy of the sound transformations. First, the air vibration. So the air vibration, they are converted to vibration of the tympanic membrane and ossicle of the middle ear. because if the air vibration receive the sound, so the hair cells in the cochlea that is vibrate and translated the sound into electrical signal. So in these electrical signals that they are transmitted to the nerve. But but if when sounds vibrates the air, it they are also translated into nerve and pulse, and then the impulse happens, they travel to the brain where they are interpreted by the brain as sound. So the hearing happen within the inner ear can be easily damaged because of by excessively loud noise and causing sensory hearing and loss.
The process of hearing with the occurrence of a sound is imitative when an event moves and causes a motion or vibration in air. When this air movement stimulates the air, a sound is heard. So the starting processing of hearing is start or begin on something what happened with a sound. Sounds begin when their attempt move and cause a motion or vibration in air. When this air movement causes a sound in the ear, this sound will be heard. In a human ear, a sound wave is transmitted through four separate medium along the auditory system. Before a sound is perceived, in the outer ear, in the middle ear mechanical, in the inner ear liquid, into the brain neural. Before you heard or perceive the sound, there are four ways to transmit it of separate medium along the auditory system. First, outer ear. Second, middle ear mechanical. Third, inner ear liquid. And the last is brain neural. Sound transmission through the outer ear. To transfer the sound is through by the outer ear, include the portion of the ear that we see the pinna or auricle in the canal. Air transmitted sound waves are directed toward the delicate hearing mechanism with the help of the outer ear, first by the pinna, which gently funnels sound waves into the ear canal, and then by the ear canal. The help of outer ear, it is passed to transmitted of the sound to the middle ear mechanical, and in the pinna is the collective directed sound wave traveling in the ear into the ear canal or internal auditory meatus. Sound transmission through the middle ear. The sound is also transferred by the middle ear. It is composed of the tympanic membranes in the cavity, which houses of the ossicular chain.
When the air movement strikes the tympanic membrane or eardrum moves. At this point, the energy generated through a sound wave is transferred from a medium of air to the, which is solid in the middle ear. The ossicular chain of the middle ear connects to the eardrums via the malleus, so that any motion of the eardrum set the three later bones of the ossicular chain into motion. Sound transmission through the inner ear. So, hearing the process by which the air transfers sound, vibration, and the external environment into nerve impulses that are conveyed to the brain, will they are interpreted as sound. The ossicular chain transfer energy from a solid medium to the fluid medium of the inner ear via the steps. The steps is attached to the overview. Movement of the overview creates motion in the cochlear fluid and along the basilar membrane. Motion along the basilar membrane excite frequency specific area of the organs of faculty, which in turn stimulate a series of nerve endings. So hearing starts with the outer air when a sound is made outside. The outer air, the sound waves or vibration travel down the external auditory canal and strike the eardrum tympanic membrane. The eardrum vibrates. The vibration are then passed to three tiny bones in the middle ear, called the ossicles. The ossicles amplify the sound. These send the sound waves to the inner ear and into the fluid, hearing organ, cochlea. Sound transmission to the brain. With the initiation of the nerve impulses, another change in medium occurs from fluid to neural. Nerve impulses are relayed through the HCN through various nuclei along the auditory pathway to a rest to the brain. It is the brain that interprets the neural impulses and creates a tooth, picture, or other recognized symbol. So once the sound waves reach the inner ear, they are converted into electrical impulses. The auditory nerve sends these impulses to the brain. The brain then translates these electrical impulses as sound.
Normal function of hearing. It can be used to alert and communicate pressure and feel. It is the conscious appreciation of the presentation perceives as a sound in order to do this appreciate. And signal most react to higher and part of the brain. The function of the earth to do convert and physical presentation into encoded nervous impulse. The Earth are organizations that provide true mind function of hearing and balance. The defines in our specialized structure garden health cells. Hearing, the eardrums and bronchitis. When sound wave enter the eardrum canal, oscillate in three tiny bones including the staph and the smallest bones in the body. Pass and presentation to over and window, with is not membrane and at the entrance to the inner ear. Balance balance and achieve in through combination of the sensory organ and the inner ear in visual input and information received from the receptor in the body, especially around during that information process and the cerebellum and the cerebral context of the brain allow in the body to copy in changes in speed and the direction of the head. The earth is divided into three parts, outer and inner. The outer and earth include an earthen canal that is inlined with inhaled in glands that secrete wax in the part of the earth, providing protection in the channel zone. The auricle or phenon is the most visible part of the outer air, and what most people are in referring to when they use the word L. Middle L, three-tenth moving bones that molecules enclose and stiff within the middle L and transfer sound presentation from the L drum to the inner air. In the middle L is not important because it is filled with numerous air in space and provided routes for infection to travel. It is also in that location of Eustachian to and equalize that yield and pressure between the inner and outer surfaces on the tympanic membrane eardrum. The inner air, the inner air also called in the leverate operates the body's sense of balance and the contains the hearing organ, a bone causing house and complex system of membranous cells. The inner ear and called the labyrinth because of in its complex shape there are into main section within the inner and bone labyrinth and the membranous labyrinth. The cochlea, and the hearing organ. It is located inside the inner ear. The snail-like cochlea is made up of three piled chambers that spin around and bone called in, which contain a central channel called in cochlear duct inside cochlear duct in the main hearing organ. The spinal zap, an organ of Corti, housing cells inside the organ of Corti, detects in sound and sends information through and cochlear nerve. The sound begins to the outer elf, moved into the middle elf, and finally enters the inner elf and the striated network of nerves, bones, and canal and cells.
Abnormalities of hearing. For example, a buildup of wax in the ear or an ear infection can cause hearing loss that goes away with treatment. In sensory neural hearing loss, sound reaches the inner ear, but a problem in the inner ear or in the nerves that allow you to hear prevents proper hearing. This type of hearing loss is usually permanent. Air wax, also called cerumen, is made by the body to protect the ears. The earwax has both lubricating and antibacterial properties. Untreated buildup can lead to hearing loss, irritation, pain in the ear, dizziness, ringing in the ears, and other problems. Most of the time, the old earwax is moved through the ear canal by jaw motion, like chewing, while the skin in your ear grows from the inside out. When it reaches the outside of the ear, it flex. We say that earwax is impacted when it has built up in the ear canals to such a point that there may be signs that something isn't quite right. It's important to note that most people might never need to clean their ears. Ears are designed to clean themselves. Earwax buildup and blockage often happens when people use items like cotton swab or bobby pins to try to clean their ears. This only pushes the earwax farther into the ears and can also cause injury. A buildup of earwax might also make it difficult to see into the ear, which may result in potential problems going undiagnosed. Abnormalities of hearing. For example,
Today, our topic is about anatomy and physiology of a nervous system. So, I discuss the six hearing process to how we hear. The hearing process, in essence, our ears work to alter the acoustic stimulus that enters and moves through our ear canals into a form of neural code that our brains can decipher, process, and comprehend. So, here are six basic steps to how we hear. So, number one, sound transfers into the ear canal and causes the eardrum to move. Because the sound waves enter the outer ear and travel through a narrow passageway called the ear canal, which leads to the eardrum. Because the ear canal has an entryway for sound waves which get propelled toward the tympanic membrane, known as the eardrum. When sounds enter the middle ear, they are transmitted to tiny bones called the ossicles, which consist of the stapes, encus, and malleus. Sound waves enter the outer ear and travel through a narrow passageway called the ear canal, which leads to the eardrum. The eardrum vibrates from the incoming sound waves and sends these vibrations to three tiny bones in the middle ear. So, to transfer sounds from the eardrum vibrates. The vibrations are then passed three tiny bones in the middle ear called the ossicle. Amplify the sounds, they send the sounds wave to the inner ear and into the fluid-bearing organ cochlea. So, what happens when the eardrum are ready to move? The vibration continues through the bones of the middle ear because the vibration allow you to hear. Your hearing can suffer if your eardrum is damaged. A ruptured eardrum is also called a perforated eardrum. In rare cases, this condition can cause permanent hearing loss. So let's move to the number 2. Number 2, the eardrum will vibrate with the deferent sounds. Because the eardrum vibrates from the incoming sound waves and sends this vibration to 3 tiny bones in the middle ear. These bones are called the malleus, encus, and steps. The eardrum will vibrate with the different sounds. It because these sounds vibrations make their way through the ossicles to the cochlea. The auditory nerve moves signals to the brain where they are then translated into recognizable and meaningful sounds. It is the brain that hears. What vibrates in the eardrum? It is because to collect sound waves and channels them into the ear canal external auditory meats, where the sound is amplified. The reason why the sound wave them travel toward a flexible oval membrane at the end of the ear canal that they called eardrum or tympanic membrane sound wave causes the eardrum vibrates. So let's move to the number 3. Number 3. These sound vibration make their way through the ossicle to the cochlea because the bones in the middle ear amplify or increase the sound's vibrations and send them to the cochlea. A snare-safe structure filled with fluid in the inner ear. An elastic partition runs from the beginning to the end of the cochlea, splitting it into an upper and lower part. This partition is called the basilar membrane because it serves as the base or ground floor on which key hearing structure. The ossicle amplify the sound. They send the sound waves to the inner ear and into the fluid-filled hearing organ cochlea. Once the sound waves reach the inner ear, they are converted into electrical impulse. The auditory nerves send these impulse to the brain. So let's move to the number 4. Sounds vibrations make the fluid in the cochlea trouble like ocean. Because once the vibration causes the fluid inside the cochlea to ripple, a troubling wave forms along the basilar membrane. Ear cells, sensory cells sitting on top of the basilar membrane ride the wave. Ear cells near the wide end of the snail-shaped cochlea detect higher pitch sounds, such as an infant crying. Those closer to the center detect lower pitch sounds, such as large dog barking. Sounds vibration make the fluid in the cochlea travel like ocean waves. Movement of fluid and turn makes the ear cells, the auditory nerves, pick up any neural signal created by the ear cells. The auditory nerves move signals to the brain where they are then translated into recognizable and meaningful sound. So let's move to the number 5. The movement of fluid and turn make the ear cells, the auditory nerve picks up any neural signals created by the ear cells. Ear cells at one end of the cochlea transfers low-pitched sounds and information, and ear cells at the opposite end transfers high-pitched sound and information. So, as the ear cells move up and down, microscopic curl-like projection, known as stereocilia, that first on top of the ear cells pump against an overlying structure and bend. Bending causes fold-like channels, which are at the tips of the stereocilia, to open up. When that happens, chemical rush into the cells, creating an electrical signal. When the heat turns, fluid in one or more semicellular ducts passes against the cupula and bends the cilia of the ear cells, bending the stereocilia toward the kinocilium depolarized. The cells end results and increase the apparent activity ear cells in the organ of Corti and the cochlea of the ear response to sounds. The fluid term endolymph, which surrounds the ear cells, is rich in potassium. The actively maintain a unique imbalance, provide an energy source which is used to trigger neural action potential when the hair cells are moved. So let's move to the last number 6. Number 6. The auditory nerves move signal to the brain when they are translated into recognizable and meaningful sounds. It is the brain that hears. The auditory nerves carries these electrical signals to the brain, which turns it into a sounds that we recognize and understand. So our hearing process truly connects us to the soundscapes of our surrounding environment. Our hearing system provides us with an amazing ability to identify and comprehend the most minuscule acoustic cues. In fact, our brains are capable of storing the neural equivalent of acoustic patterns like music, voice, danger sounds, and environmental sounds. This similarity makes it much easier for us to recognize and process both familiar and unfamiliar sounds. So this sample hearing loss occurs when sounds that are typically loud become softer and less intelligible. This is a result of our brain being measured through a loss of audibility. Information also becomes distorted as it reaches the brain, distracting the quality of our hearing. So let's look to the picture of ear. This picture is the part of ear. So this is a external auditory canal. The pulses to tracking the causes of eardrum to vibrate. So the eardrum, malleus, one of the small bone. Do one of the small bone, also called hammer, to transmit sounds to the ankles and to the steps. So
Assalamualaikum warahmatullahi ta'ala wabarakatuh. I am Zairalyn Isnaji Hassan and I'm going to tackle about transmission the sound to the central nervous system. In order for a sound to be transmitted to the central nervous system, the energy of the sound undergoes three transformations. First, the air vibrations are converted to vibrations of tympanic membrane and ossicles of the middle ear. These in turn become vibrations in the fluid within the cochlea. Finally, the fluid vibrations set up traveling waves along the basilar membrane that stimulate the hair cells of the organ of Corti. These cells convert the sound vibrations to nerve impulses in the fibres of the cochlear nerve, which transmits them the brainstem, from which they are relayed after extensive processing to the primary auditory area of the cerebral cortex, the ultimate center of the brain for hearing. Only when the nerve impulses reach this area does the listener become aware of the sound.
let's talk about 5 ways to prevent hearing loss. First is avoid loud noises. The best way to avoid noises induce hearing loss is to keep away from loudness as much as you can. Generally, a noise is probably loud enough to damage your hearing if you have to raise your voice to talk to others people. You cannot hear what people nearby are saying. It hurts your ears. You have ringing in your ears, muffled hearing afterwards. Shouting 50 dB, conversation 60 dB, busy traffic 70 to 85 dB, motorbike 90 dB, and listening to music on full volume through headphones 100 to 110 dB. Then, plain talking off is
120 dB. You can get smartphone apps that measure noise level, but make sure they're set up properly to get a more accurate reading. So let's proceed to number 2. Number 2 is take care when listening to music. First is listening to loud music through earphones and headphones is one of the biggest dangers to your hearing. To help avoid damaging your hearing, use noise cancelling earphones or headphones. Do not just turn the volume up to cover up outside noise. Turn the volume up just enough so you can hear your music comfortable but no higher. Do not listen to music at more than 60% of the maximum volume. Some devices have settings you can use to limit the volume automatically. Do not use earphones or headphones for more than an hour at a time. Take a break for at least 5 minutes every hour. Even just turning down the volume a little bit can make a big difference to your risk of hearing damage. So let's proceed to number 3. Number 3 is protect your hearing during loud events and activities. First is to protect your hearing during loud activities and events such as nightclubs, gates, or sports events. More away from sources of loud noises such as loudspeakers. Try to take a break from the noise every 15 minutes. Give your hearing about 18 hours to recover after exposure to a lot of loud noises. Consider wearing earplugs. You can buy reusable musician earplugs that reduce the volume of music but do not multiply it.
Take precaution at work. If you're exposed to loud noises through your work, speak to your human resources or HR department or occupational health manager. Your employer is obliged to make changes to reduce your exposure to loud noise, for example, by switching to quieter equipment if possible, making sure you're not exposed to loud noise for long periods, providing hearing protection such as ear muffs or earplugs. Make sure you wear any hearing protection you're given. And working in every places should have a peaceful, like for example, if you have work, so if there's a noise you can focus on or concentrate of what you are doing. By this you can address the problem to human resources department so that it will listen the noise and adjust the equipment that causes noises or it's either environmental noises, and make sure you are providing hearing protection as much as possible, providing protection as much as possible because it is important so that you can't be distracted somehow. And get your hearing tested. Get a hearing test as soon as possible if you're worried you might be losing your hearing. The earlier hearing loss is picked up, the earlier something can be done about it. You might also want to consider having regular hearing checks once a year, say, if you're at a higher risk of noise induced hearing loss. For example, if you're a musician or work in noisy environments, as a worker, you must have a checkup for your hearing ability at least once a year because it is important for you to evaluate your hearing strength and weakness. If you are prone to noise such as music, environmental noise, and physiological psychological noise, and there a tendency you will be having a hearing problem that you must to test into the doctor of possible to your safety and healthy ears.